Students, now we are moving in the last part of the chapter, and from the beginning it is interconversion of a state of matter. There are two physical factors by which a state of matter depend, that is temperature and pressure. Solid can be converted into liquid. See, solid can be converted into liquid. How it can be converted into liquids? For example, you have ice. So ice converted into water. How it will convert into the water? When you increase the temperature. When you increase the temperature, ice can be converted into water. That means solid converted into the liquid, right? Similarly, water also converted into gas when you increase the temperature, right? Now, when you decrease the temperature, if the temperature is decreased, then what will happen? The gases can be condenses into the water, liquefied into water. When you decrease the temperature of water, then what will happen? It can convert it into ice. That means the gases can be converted into the water and liquid, or liquid can be converted into the solid by decreasing the temperature, and vice versa. Vice versa means opposite. Solid can be converted into liquid and liquid can be converted into gas by increasing the temperature. So this is one factor. Gases can be converted to liquid and liquid can be converted to solid by increasing pressure. Here you can see next factor is pressure. Gases can be converted in liquid. When you increase the pressure is increased, the gas is converted into liquid, right? And solid by increasing the pressure and decreasing the temperature. Clear? So if you increase the pressure and decrease the temperature, then gas is converted into solid also. So these are two factors. Latent heat of fusion. See, heat required to change 1 kg of solid into liquid. 1 kg of solid, when solid changes into liquid. For example, suppose you have ice. How you can change the ice into water? By only by only by only increasing in the temperature. That means you need to give the heat has to be given when solid is changing into liquid. Now, what is amount of heat is given? कितने अमाउंट में हीट हमें देनी पड़ेगी? That heat is called latent heat of fusion. Fusion is also known as melting. Remember this, na? Sometimes you will get confused. So if 1 kg is solid is changing into liquid, so whatever the amount is required to change solid into liquid, right, that is called latent heat of fusion. And condition is applied. Condition is what? At atmospheric pressure. Clear? Now next is vaporization. Vaporization means changing liquid into gas. Next topic is latent heat of vaporization. Again you can see the vaporization you have heard about liquid changes into gas. So when liquid changes into gas, you need to increase the temperature, right? That means you need to give the heat. So whatever amount you have given to change 1 kg of liquid into gas at atmospheric pressure and at its boiling point, that is called latent heat of vaporization. What is condensation? When the liquid is changes into solid or gases changes into liquid. Clear? Gases changes into liquid, or liquid when liquid changes into solid, that is also solidification. And condensation means when gases, especially gases, changes into liquid. Now moving ahead, sublimation. So what is sublimation? When solid directly changes into gas. Example I have given to you. For example, you see iodine, right? Iodine. Another example, You might have seen naphthalene balls जो हम कपड़ों में की अलमारी में रखते हैं. Clear? There are many other example also. Ammonium chloride, camphor you might have seen, camphor also. So there are plenty of example which directly changes into gas. The solid changes into gas, right? If the gas changes into solid, then it is deposition. Okay. Now boiling point, temperature at which liquid changes into gas, right? That is called boiling point. It is for water, it is 373 Kelvin or 100 degrees Celsius. Melting point, when solid changes into liquid, that is called melting point. Now moving to the exercise question answers. See, the question is, give reason for the following observation. Just now we have discussed about naphthalene balls which disappear with time without leaving any solid. And what is the reason behind it? The reason is sublimation. What is sublimation? Sublimation is when solid directly changes into gas. Right? Naphthalene undergoes sublimation easily. That is the change of state. Naphthalene from solid to gas takes place easily. Next question is, we can get the smell of perfume sitting several meters away. So here what is the concept? Concept is diffusion. Diffusion concept is applied. So what is the answer? Gaseous particles passes high speed and large space between them. So here we are talking about gas. So gas is having higher kinetic energy, right? Higher kinetic energy. So the rate of diffusion will be more. So particles of perfume diffuses into these gaseous particle at a very fast rate and reach our nostril. This enables us to smell the perfume from distance. Now arrange the following substance in increasing order of force of attraction. Here you can see water, sugar and oxygen is given. Water, sugar and oxygen is given. So sugar is solid. The force of attraction between the particle of sugar will be very strong. Water is liquid. The force of attraction here are weaker than solid. And oxygen is a gas, so the force of attraction will be weakest in the gas. So what will be the increasing order? The first oxygen will come, then water will come, then sugar will come. If suppose here next question is, what is the physical state? So here you can see the physical state of water at 25 degrees Celsius. That means room temperature. At room temperature the water exists in liquid state. Clear? At 0 degrees Celsius the water exists in the form of ice, as well as the ice also melts, so liquid state also. So 0 डिग्री सेल्सियस पे वाटर क्या होगा? आइस के फॉर्म में भी होगा और लिक्विड के फॉर्म में भी होगा. एट 100 डिग्री सेल्सियस water available in liquid form. Why? Because it's a boiling point of water, so in the form of liquid and in the form of gas, in both the form it will exist at 100 degree Celsius. Now next question is, water at room temperature is a liquid. Why? At room temperature, that is most probably we are taking 25 degrees Celsius, because water can flow at room temperature, right? And it's follow all the properties of liquid. Similarly, an iron almirah is solid at room temperature. Why? Because it follow all the properties of solid. It has definite shape, fixed volume, occupy the space, right? So these are the certain explanation about the answers. They are much easier than others, right? Moving ahead, why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Here you can see 273 Kelvin means 0 degree Celsius. At 0 degree Celsius you have ice, right? And at the same temperature you have water. Clear? So water The temperature of water will be what? 25 about, right? And ice is having 0 degree Celsius. So here what is the concept? At ice at 273 Kelvin has less energy than water, right? So water possesses the additional latent heat of energy since it is in the liquid state. It is in the liquid state, so additional energy is having, right? So additional energy in the form of latent heat of fusion. So hence 273 Kelvin ice is more effective. Why? Because when ice has to change into liquid, it need to take the temperature. That means it has less latent heat, right? And it has more heat. So that is why ice is more effective in cooling at 273 Kelvin. Next question is, what produces more severe burn, boiling water or steam? Again the same question will be asked. Here you can see the water is there, boiling water and steam. You know that liquid and gas, they are two things which have more energy, more heat. The gas occupy the more heat. Heat is more in the form of gas, heat is less in the form of liquid. So here we will consider that heat latent heat of vaporization, right? Here liquid and gas, they are talking about liquid and gas. So it is, the formula is latent heat of vaporization, right? So what we can say, the steam is having more latent heat of vaporization than the boiling water. So steam are more severe than the boiling water, right? That's it for these questions. Thank you.